Hello, welcome to another episode of the DSL podcast. I am your host, Dave Cole, and our guest this week is Jayesh Govindarajan, and he is the SVP of Data Science and Engineering at Salesforce. So welcome to the DSL podcast, Jayesh.
Thank you, Dave. Great to be here.
Great. So our agenda today with Jayesh here is to talk a little bit about his background, I think is unique. Jayesh, you came from an engineering background and are now a DSL, so sort of a pure software engineer. I think you're the first DSL podcast guest that we've had who has a pure engineering background. So I want to talk a little bit about that and how that sort of helped you, or, you know, I'm curious to see the makeup of your team based on your background. Are people sort of in your mold, or are they more like pure data scientists? And then, of course, we're going to talk about the Einstein platform. So Jayesh, you're looking at your background. You worked at Avaya. You also then went on to create a startup called Minhash, which was acquired by Salesforce about 5 years ago. And then you moved into your current role working at Salesforce and really helping to build out the Einstein platform. So before we talk about our agenda topics, maybe you can just help the audience who might not be familiar with Einstein. Hopefully they are. But understand a little bit about what Einstein is.
Sure, I think that's a great question. Like you said, Dave, I lead several of Einstein's efforts here at Salesforce. Broadly, Einstein's sort of two parts of components. One is Einstein for sort of our clouds that integrated machine learning and AI components tied deeply to use cases within sales, service, and B2B marketing. Those are our three big clouds. There's more as well. In addition, I also lead teams that build foundational components such as for assisting humans to complete their enterprise task, as well as fully automation self-service components such as bots. So broadly, think of it like layered cake. There's like a foundational layer which cuts across many of these components, and then there is verticalized AI ML components specific for sales professionals, service agents, as well as marketers.
So when you talk about the foundational aspects of your team, are you talking about work that is helping the Salesforce, the company, or are you talking about sort of things that are helping actual Salesforce customers?
That's a really good question. Everything my team builds is, in essence, products that go out to Salesforce's customers. When they're performing CRM activities, our products, our AI ML components essentially help them complete the task or automate a task, or sort of assist them with getting their job done on the Salesforce platform.
Yeah. So today, I definitely want to talk, dig into that, right? Which is to learn a little bit more about how you go about doing that. How do you figure out what tasks to automate? How do you go about embedding it into the Salesforce platform? And I mean, obviously, the Salesforce platform is massive and has, just in terms of number of users and active users, it boggles the mind, and it's got to be a particular challenge, right, to take some of these models and actually embed them in some way, shape, or form into a SaaS solution of that, a SaaS platform of that size. So, I would love to pick your brain here. How you help our audience learn a little bit more about how you do that at scale. But before we dive into that, let's talk a little bit about your background. So you started as a software engineer, and then it wasn't until your Minhash startup that it looked to me, just looking at LinkedIn and our conversations, that you really sort of got the bug, and the data science bug, and sort of moved in that area. Is that fair to say, or did it start before that?
I think it started a little bit before that, but with breaks in between, focused more on sort of engineering. So I've had but I think the right way to characterize is a long and meandering path into data science. So I studied computer science many years ago, and really my first exposure to writing programs that learn from data was actually like building my master's thesis, components for my master's thesis, which was actually working on geo features for search ranking algorithms. This was, of course, before Google was a thing. But right after that, I sort of went into a startup, and as you well know, you sort of wear all hats in a startup. I was sort of the back-end engineer there, so I kind of lost track of building components that learn from data for a few years while I was at the startup, and then picked it back up when I joined Oracle several years later. I joined a team that was building essentially clinical decision support systems, which I found quite fascinating in the breadth of opportunities available. Still an unsolved problem, really. And really, that's kind of where I got into doing things like building models for predicting risk in provider settings, doing all kinds of number crunching for payers to optimize billing. So the entire gamut, before it was kind of called machine learning, it was called statistics, right? But even there, a lot of sort of my experience that eventually came in quite handy was building sort of scalable end-to-end data-driven systems. In essence, wrapping analytics and statistics into a product and shipping it. So that was sort of, I'd say, my first real introduction to doing, I wouldn't say machine learning, but at least analytics and statistics sort of at scale, wrapping it into a product. After that, I ran ad tech for a startup here in the Valley called Skyrider for about 3 years. And again, I think ad systems, as you well know, real-time complex event processing with the matching component built in for surfacing the right ad. So I think that was sort of I'd say strong learning ground for doing what I was about to do next, which is machine learning at scale.
Right, but you were managing. I mean, during these last two, the Skyrider and at Oracle, like you were either an engineer as your primary job, and yes, there were certainly some data components to it, and some analytic components to it, but you were managing teams that were writing code.
Absolutely.
And committing code to a repo and so on and so forth. So while there might have been some peripheral sort of data, you were primarily an engineer, right?
Yes.
There's a QA team and everything else.
Building systems, getting things in production, running them at scale. Sort of that was sort of 70% of the job. The model was like one small piece that was part of the equation as well.
So if we fast forward and we look at your team today at Salesforce, I mean, I imagine that you still need to have, because so much of the work that you're doing is data science products that are sort of embedded into the SaaS platform. I have to guess that it's a mixture. Your team will have a mixture of sort of data science and engineers, much more so than say, an average sort of, Fortune 500 companies data science team. Is that fair to say?
Yeah, absolutely. I think it's a very, very cross-functional team. We have software engineers that are full-stack engineers, UX folks that specialize in the front end. We have data scientists that work on model building, algorithm building, and we have machine learning engineers that continually evaluate this in production. And they're really focused on getting these models into production. So it's truly a cross-functional team that sort of cuts across all areas. And I feel like that is super important to doing things at scale, especially building AI and ML for the enterprise. I think it takes...
So having and when you say cross-functional team, what do you specifically mean by that? You mean it's important to have not just data scientists, but also folks who really know how to code and really know how to put a model embedded into like a SaaS type solution?
Yeah, I mean, I think let's take the typical sort of life cycle of a machine learning component in production. You typically start with working with a handful of customers, going deep into the problem. You don't necessarily want to build the best model right there. You just want to figure out what the bounds of the problems are. What's acceptable performance in a customer context. And to do that, we have people that can prototype, can build a model pretty quickly. Some engineers, some UX people that can build a prototype with customers. And once we sort of get to a point where we feel like, okay, it's ready to build this at scale, we then sort of create an entire team around it, get it into production, start to ask some harder questions around, does this model generalize across customers, across for that particular task, which is a pretty expensive process. If you can imagine building something that goes out to hundreds and thousands of customers is an expensive process, and you want to make your fail fast in the early phases so that when you're ready to go, you have a full team that can go build this out at scale.
All right, so now we're getting into the process of what your team does, which is great. Yeah. We're segueing into sort of the Einstein conversation. So along these lines, it sounds like your process, and based on what you just said, to paraphrase, is when your team has an idea of a new feature to build, a new sort of data science type product to build and brand it as some Einstein component. They start with a small handful of customers and sort of a POV type approach. Now, are these customers aware of it, or is there something that they like see that just says hey, do you want to opt in to this, or is it done in sort of partnership with them because you know that they're interested in this particular feature?
It is very much in partnership with customers. Okay. So we're very clear earlier on that we want to make sure that this is a problem worth solving. Meaning it is going to either help users of this product get more efficient, or if they're not getting more efficient, help save money in some way, or help them grow their business in a different dimension. So the value proposition needs to be pretty clear. Right. As you can imagine, if it's not, it's a self-selecting audience. Like if you keep trying something, it's not working, it's likely not a great idea that you want to pursue in any case.
Right. And another thing you said too was you're starting with a small cohort of customers. And how many is that? Is that like less than 10 or
typically? Yes.
Less than 10. So you're starting with like less than 10 customers, but then you have to think to yourself, is this going to be useful to all 100,000 plus customers that Salesforce has? And is the solution that we're putting together, to your point, can it be generalized? Can it, is it going to be sort of extensible to all of those 100,000 customers, or is it not going to be used at all? So how do you go about making that determination?
Yeah, I think that's a great question. I think it's sort of, in my experience, what works really well is understanding of the bounds of what good looks like. So if you've built a model, it's trying to solve a specific problem, you're always going to have customers for whom it may not work perfectly well, right? And I think one of the things that we've done quite well is design products where those failure modes are taken care of well. Models don't spit out information that's not going to be complete. That's going to be completely useless over and over again. You bring in a human in the loop. You have them review it if you're not sure, and then you sort of use it for the job to be done. So this is kind of what I mean when I say that a cross-functional team is key to this. What I just described to you, this ability to pull in a human, get in their inputs before you tweak a model, maybe unbeknownst to them, is completely a UX challenge, right? And I think that's what I mean when I say I think the best and the most scalable solutions that we're able to put out there have that mix of great user interface, and great engineering, great user interface, great science that sort of comes together. You asked about.
Can you talk?
Sorry, you asked a bit about generalizability, which I want to touch upon more. Once we've had a successful pilot, really is the beginning of the next stage in the journey, which is the machine learning component we've built going to generalize across all customers? It will not without tuning. So how can we build systems that customers can tune themselves? What kind of training samples can they give this component so that it's a good fit for them, for their use case? The way it kind of breaks down is you have systems that can work great with a global model. Like for example, if you're trying to recommend articles, a global model will work reasonably well for that. But if you're trying to help an agent close a deal that is very specific to your company, your processes, all the data that you might collect, which could be very different for different companies. So that's kind of where the problem space kind of splits into: are you building something that is a specific vertical solution and you want to go crush that problem, versus are you building something horizontal, like maybe a chatbot or a knowledge intelligence component, which has the ability to go broader.
Yeah, I'd like to do a thought experiment here on. So let's say, and I don't. You'll have to help me, Jayesh, but like I assume there is an ability within the Salesforce platform that allows me to make predictions. So allow me to understand, which of my, Salesforce opportunities have the highest likelihood to close, this in some time frame, this quarter, and things like that, right? So I imagine that the features that go into that model, to your point, will differ from one company to the next, right? It's not a one size fits all type solution when you're trying to predict whether or not an opportunity will close. So when you were building this as a capability, as a feature within the Salesforce platform, I assume that you're having to think, all right, since we're not just using the same data set every single time, we have to allow the capability to train a model based on different types of data sets, and for the the person who's actually training this to determine whether or not the model's going to be good and ready to be trusted. So maybe you can walk us through like because those are things that not every data scientist has to think about, right? Most data scientists are working with a confined data set, and they don't have to think outside of their specific problem, and they don't have to generalize it to thousands of customers, right? Yeah. So do I have that right? I mean, did I summarize part of the challenge?
You did, yeah.
Cool. So how does your data science team go about doing that? I mean, it's almost like you're not just building models, but you're building the capability for your Salesforce users to build models. Yeah. Is that right?
No, that's exactly right. Let's probably instructive if we take an example. That's currently being used by our customers. One of the things that we built and shipped, which has really taken off during the pandemic, is our chatbot engine. A lot of what chatbot engines, not just Salesforce in general, do is understand conversations and take you down a certain path to get your task done. People don't talk to Salesforce chatbots for doing chit chat. They want to get something done, and they want to get there quickly. Now, the intents that you might need to nail so that you can send the customer conversation down a certain path is going to be different for different customers. For example, if you're a retail customer, you might have intents that are something like, what's my order status? If you're an IT customer, completely different intent. Things like, help me reset my password. If you're a healthcare company, would be like getting appointments going. So broadly, there is this entire sort of gamut of intents that are striped by industry, right? Mm-hmm. How does one build a solution that is going to cut across all of those? I think in that case, what we've done in that case is basically built an intent engine, which comes pre-trained based on a language model that is kind of global in nature. And then when a customer implements the product, we have a training game that's part of the product setup process, which essentially fine-tunes the intents to the specific needs of that customer. And what's amazing to see is that now that it's completely scaled out, we have thousands of customers that use it now. You can see the industry specialization appear, although we never put it there. Mm-hmm. It's just based on what customers fine-tune. You tune vocabulary for every industry specific to what you play in.
But is the chatbot engine, when you say it's an intent engine, help me understand that a little better. Is it specific to the intent? So it says like, hey, here's sort of the, if you're trying to get an order status, like this is the data that you should train it on, and you need to use this flavor of the chatbot engine. Is that kind of how is that what you mean by intent?
Think of it like a hierarchy. Engine? There is a lower level model that is pre-trained, so it'll understand things like order. But if you call order something else in your industry, it will not make that mapping until you give it some more training data to make that association. So over time, in essence, we do order management pretty well because it's part of common parlance or common vocabulary that you and I use.
Right.
But if the concept of an order is different in a different industry, that would look different. Like that would need to be fine-tuned, especially for that industry.
Yeah, like let's say it was like instead of order status, it was like a support ticket status. Like, what's the status of my support ticket? It's like sort of the same thing. You're looking up status of, essentially like a transaction, so to speak, an interaction. But the language you would use to check on it might be very different.
Yeah, exactly. Right? Yeah, and it's
Got it.
For example, when you say I want to reset my password, there's a very specific meaning to that. But resetting, I'm running out of examples here, but you can think of reset in a context that's different from a password.
Okay.
And you would need to know what to reset. If you implemented the solution, you would know what exactly to reset.
Right. So the intent might be to reset something. That something could be a password in the case of like an IT sort of vertical, type company, but it could be, I don't know, resetting. Like in a healthcare context, subscription or something.
I mean, in a healthcare context, you'd be resetting your elbow if you, if you pop it, for example, right. As morbid as that sounds.
Yeah. Like it's out of joint or something. Okay, got it. So I guess one sort of taking a step back, like one sort of piece of advice is if you are having to sort of create more of a generalized model that can go across industry, is to look at intent. Like look at actually building models that can be specific by intent, and then allowing sort of those industries to take that and make it sort of their own within their own specific industries, because there might be slightly different ways in which you might check an order status between, say, like I was saying before, like a retail order status versus like a support ticket, which might be generalized to sort of IT, type company. Okay, so that makes a lot of sense. That's one sort of nice, interesting nugget and sort of takeaway. How about the sort of problem itself of you've determined that you want to build a chatbot, let's say, and you rolled it out for a couple of customers. It works great, but then you want to roll this more broadly out to the entire Salesforce customer base. You mentioned that at that point you actually build out a team that is specific to that, and that team is a cross-functional team of sort of UX, ML engineer, data scientists. Anything else I'm missing out of those three?
Yeah, no, that's kind of my team, but we also have product people as part of the mix. We have documentation specialists. So yeah, it's a pretty full.
Got it. So yeah, but then this team will focus and build. And are they taking the prototype and sort of running with it, or are they almost like rewriting it from scratch, or does it sort of depend?
Yeah, I think it takes a while to convince people that it is a prototype. And that means that when it's ready for prime time, you have to think about doing a full rewrite on it. So
So most likely it's a full rewrite, right? Full rewrite. And then they build it all out. And then how does it actually get rolled out? Does it get rolled out all at once, or is it like does it get rolled out slowly? Across the customer base. Is there any A/B testing? How are you tracking the success of the new feature that you've added? Like, how does that all work?
Yeah, I mean, one of the things I love about this job is we are not just happy shipping shelfware to customers. One of the things we start to track right after we launch the product is essentially usage. Pretty much everything is instrumented, in the whole sort of usage value chain of the customer, and the rollout initially is kind of slow because we're still kind of figuring out how to tell the story, how to tell the narrative. But once it sort of gets up to 40, 50 customers, it starts to kind of hockey stick, because customers talk to each other. they know what's working well. We have a much better sense for what to tune better. And one of the things I like to say is that we have this 1 to 10 customer journey, like 10 to 100 customer journey, or maybe, and then 100 to 1,000 customer journey. These are like, they're very different challenges at each stage as we scale, and then 1,000 up is completely different.
Basically, the powers of 10,
powers of 10,
if you will.
Yeah, orders of magnitude.
Yeah. So, exactly. So as you're rolling this out, and as you're just it's sort of growing, like I imagine part of this too is also collecting customer feedback. So is that sort of the product manager's job, is to to reach out to customers and just see how things are going? And I imagine also you're looking at that telemetry, looking at that usage data to make sure that not only is it being used, but is it being used sort of successfully?
Yeah,
no errors, no issues.
Exactly, and telemetry, it tells you a lot, but there's really no substitute for great anecdotes. It doesn't tell you where to go next, and I think that's one of the key things that we do is, like, once we launch something, it goes to GA. There's a almost continuous feedback process where we have user researchers with our product managers go in, talk to customers, get their feedback. Often customers would tell us directly what they want, like what's working well, what's not working well. Often sometimes that's not the case. You just have to dig deeper to understand what might be going on, what you might want to do to get to the next stage. It's not always obvious, but sometimes it is.
Sure. But I like that quote there. I'm going to put it on my wall. I think you said, telemetry doesn't tell you where to go, right? Where to go next. It sort of tells you what happened in the past, but it may not tell you, like, what the next great sort of enhancement should be for the model that you've sort of embedded. Okay. Is there anything, this last sort of parting words of wisdom, Jayesh, that you have? If somebody right now is a DSL working for a SaaS company and is sort of trying to figure out, like, the best approach to getting models into production and getting sort of models embedded into the SaaS product.
Yeah, I'd say two big things to think really hard about is, one, treat error conditions as opportunities to bring humans in the loop to train the system better. And the sooner one does that, the more options you have for the system to learn from usage. I think it's the journey. Once you've shipped V1 has only just begun. You haven't really gotten the feedback loop going. I'd say that's sort of one bit of advice for scalable systems. Second, model is just a very small part of the entire service that we run at scale. So I think those are sort of two things that I think are key for doing these sort of big rollouts.
Right. You were mentioning the UX is obviously very important. The data that you're working with. Because that's another huge challenge that your team has, right? Is that the data for each customer can be very different, right? And even within in the same industry, the data can be very different. So trying to standardize that in some way to make I have to imagine is a particular challenge. Yeah. Right. So you might say,
and really to get to that kind of scale, one needs to go through what we call day zero models, right? They need to be good enough to help customers do their job, so that they can then, as they use it more, train it more. So there is this sort of day one model, we call it sort of the cold start problem, which is quite real. You might do all the work, ship it. If your day one model isn't good enough, it doesn't get usage, and it never gets to the second stage where with usage it can get better. So I think that's the other key piece of learning, is that we think really long about, like, what does the day zero model look like? What does the day zero experience look like? Ideally, the global model works reasonably well for customers to take a crack at solving the problem. And then as the customers use it, we tune that model to specific vocabulary and sort of go from there.
Right. There's a specific vocabulary, but I also imagine there's, you're getting some ground truth, right? So if it's trying to help a Salesforce customer close deals faster and better, and you're actually seeing those deals close, right? That's a feedback loop to the engine to make sure that it's predicting which opportunities. It's to increase the accuracy of the opportunities that the Salesforce should be focusing on at the customer side. Got it. Yeah. Okay. That makes a lot of sense. So I'm going to switch gears a little bit here, Josh. I mean, I could talk to you a lot more about that. It's just sounds like a very fascinating, challenging problem that you have. But there's some common themes there that I think, we heard. Obviously, there's a lot of iterating. Like one of the things that we talk about a lot in the DSL podcast is that data science is not a one and done type thing. It's not like you're building an app and you're waiting for the next feature. You have to iterate. You have to constantly get feedback, and you have to make sure that model's continuing to be trained. A model that's trained once, sits out there, gets stale, is going to degrade over time, et cetera, et cetera. So a lot of those challenges that you mentioned, I think, are common to all. But I think also the scale that you're dealing with, and the fact that you have to generalize to a large customer base across industries, and the way in which your team goes about doing that by focusing on intent and some of the other things you mentioned, I think makes a lot of sense. So, but let's switch gears. I want to talk lastly about, you mentioned that there's sort of like three outputs of your data science team. There's sort of the foundational, assisted, and sort of fully automated. Can you dig into that and describe what exactly you mean by that in more detail?
Yeah. So I mean, I guess one of the things that this kind of happened quite naturally in looking at sort of opportunities across sort of sales, service, in general, opportunities for doing AI and machine learning within the enterprise. So three key pillars emerge. The first one is full automation. For repetitive activities, there's no reason for us to be doing mundane work. And there's enough training data for us to be able to automate that. This move...
Can you give an example of like a repetitive activity that your team would automate?
Yeah, absolutely. So for example, no one should ever have to find your order status for you. That can be completely self-service. You go to any retail website, you should have a chatbot that gives you with certainty what your order status is, when is it going to come, if it's going to be returned. Somebody should be able to ping you about what that status is. This is a classic example of there's no need to have anyone in the loop to be able to execute on that. There's a lot of examples.
Right. So eliminate humans from the as much as possible.
Free up humans to do what humans can do better.
There you go. I like it.
Which brings me to the second sort of pillar, which is building component that assists us in our daily lives as we work. Imagine you're an agent, you're a customer service agent. There's probably an expert sitting right next to you who's been doing this for 5 years. You might be the newbie. A lot of what we build is essentially components that train on the best and then help the rest catch up. The best replies that are used in the system with permission from the company is used for is permeated across the company. Imagine you're an agent, you solve a problem, you write a document. You want the next agent who gets something similar to have that document pop up as a potential solution that they could use to solve your case.
Right.
These are sort of all examples of assistive AI that's very much embedded into your day-to-day workflow. So the first one was sort of automate what you can, assist where you can. And then finally, the third one is broadly at the customer relationship management level, being able to optimize entire workflows, which is neither sort of automation nor assistive, but being able to give people full visibility into what's going on within your service center, which people with skills are doing well, which people with skills need some more training, this is sort of optimizing at a broader level. A lot of what we do falls under one of these three buckets. And in fact, my teams are organized that way. There's a team that's focused on building chatbots and automation, another one that's focused on sort of assistive intelligence, where they work pretty closely with the business units that build these solutions. And then finally, teams that look across all the data to figure out optimization opportunities for customers.
Got it. So the first one, the first category we call full automation is dealing with sort of those repetitive tasks, and a chatbot would fit into that category, meaning, this is something that a human could do, but really shouldn't be doing because it's so repetitive, and we want humans doing, things that are more value add if sort of an AI solution can replace it. And the second one you mentioned was more of that assisted, so kind of like a recommendation engine, almost like if a human were responding to an email from a customer about a complaint or an issue, sort of the recommended response might come up. So it's sort of not something that they should just copy paste, but something that they would sort of start from and modify and sort of improve upon. And then the last one is this one I need a little bit of clarification on, is sort of optimizing entire workflows. So can you give me an example of what that might be in the last category?
Yeah, so I'll give an example on what we do with several sales interactions. In order to identify opportunities to coach salespeople, you'll need the ability to go through many calls that they've been on, which is near impossible. It's not an assistive case because it's not meant for the sales agent who's in context of doing a job to get help with. It's not a case where we're trying to automate that conversation. It's a case where it's more
not yet anyway.
Yeah, not yet anyway. It's more a scenario where you're trying to build for the essentially the admins. It's not the agent, it's not the end user you're trying to help directly, but it's the admins that run the entire business, to give them visibility into what might be going well, what might not be going well, what are some opportunities to train people better, what are some opportunities where you can give them very specific advice. Maybe here's how you might want to handle pricing conversations, because I've noticed in the last 6 calls that you've been on, pricing conversations seem to get you sort of tighten up a little bit,
right.
And being able to show them exactly what part of the call there is. Now that's a problem for a machine. You cannot simply go through every call in your team of 100 sales agents to be able to give them that kind of advice. It sort of falls under the broad optimized bucket.
Right. So it'd be helping your Salesforce get more productive by sort of recommending best practices to a manager, for a particular sales account executive, what have you, or sales agent.
Yeah, exactly.
So it'd be like advice, hey, this is what we find to be the most optimal sort of series of touches that you should have with your customer, and you're sort of falling outside that optimal path. So let's have a conversation about that, right? And so that sort of nuance is left. That conversation is left to the manager, or the administrator, or what have you, to relay.
Yeah, and exactly. And in fact, it's a very different persona, because their job is not to go in and close the deal. That's someone else.
Right.
It's not the job of the supervisor to get on a call with Dave or Jayesh and solve their problem. It's to make sure that overall things are better.
Got it.
Which is a huge data challenge, actually.
Yeah, no, absolutely. Well, this has been great, Jayesh. Today we talked a little bit about your engineering background and how that's led to your current role, helping sort of embed models and data science into the Salesforce platform, also known as as Einstein. And then we talked a little bit about how you've organized your team into that foundational, assisted, and fully automated sort of focus, which I think is a great, I think that's universal and a great way to think about it for any data, DSL out there who's looking to help their customer base in their SaaS solution, for sure. I really appreciate you coming on the DSL podcast. This has been fantastic.
Thank you, Dave. It was a pleasure talking to you.
Great. If people want to reach out and get in contact with you, can they link up with you on
Absolutely.
LinkedIn, or do you have any sort of social media?
LinkedIn is perfect.
LinkedIn is the best way. Absolutely awesome. Well, hey, thanks again, and everyone out there, have a great rest of your week. Thanks,
Thank
Jayesh.
you, Dave. Bye.